So good morning. My name is Mike Niehaus. I'm a senior software development engineer with Microsoft, here to talk this morning about 64-bit Windows and whether or not it's time to deploy a 64-bit operating system. So as far as the agenda for today, we're going to try to go through and explore that from a variety of different aspects, looking at the benefits, the drawbacks, and the timing on when you might want to consider doing that. Now, I'm guessing that since most of you are in here to try to answer this question, you're probably not deploying Windows 7 yet, because this is the type of decision that really you want to make before you start deploying, not after you've already deployed. But okay, let's assume that we have lots of people still exploring Windows 7 and want to learn more about 64-bit side of things, so we'll start going through that. The other question I'd like to ask is, how many of you have purchased the x86 version of Windows 7? You people are pretty smart this morning. You're not falling for the game that you don't buy an x86 version or an x64 version. You buy Windows 7, and you can deploy either one. So as long as you have a KMS infrastructure or a Mac key or even a retail product key, they will work equally well with x86 versus x64. So you don't need to worry about which one you've bought, you just need to worry about which one you deploy. So that's what we want to focus on today. Which one are you going to deploy? You could change your mind at any point along the way and say, yeah, I've already deployed Windows 7 x86, but now I'm going to redeploy with Windows 7 x64. And from a licensing perspective, no issues. You can deploy the 64-bit without any issues. So let's dig in deeper into why you would want to look at Windows 7 x64. The biggest reason, at least initially, is going to be support for the latest hardware capabilities. With Windows 7 x64, you can access up to 192 gig of memory. You can also support UEFI machines. We'll explore both of those in a little more detail. You can also take advantage of some of the latest software capabilities, including apps that leverage larger amounts of memory, some additional OS integrity features, and just things along those lines. So that's what we're going to focus on for the whys of Windows 64, and then we'll also take a look at the why nots as well. So today, how many people in the room have a laptop that has more than 4 gig of RAM? Or 4 gig or more? A good portion of the room. How many of you are running Windows 7 x86 on a machine that has, say, more than 3 gig of RAM? That starts to get challenging, especially if you look at the machine itself. It will tell you that, yes, you have this amount of memory, but Windows can't use it. Windows is restricted to using no more than 4 gig of RAM on an x86 operating system. But practically, it can use even less than that. If you look at the address space of a PC, there are chunks of storage, chunks of RAM that are mapped out of that address space for different types of hardware that might be in the machine. So as a result, a 4 gig machine might only have 3.5 gig usable, might only have 3.2 gig usable. A lot of it really comes down to what kind of video card you have in the machine and how much video RAM is in that video card. The fancier the video card, the more RAM it robs from that 4 gig that's available. So if you have a 3 gig machine running an x86 OS, generally you don't have any issues, because I've never seen a machine that eats up more than a gig of that address space. But once you go up to a 4 gig machine, you're not getting full use of that 4 gig of RAM. And if you ever buy a machine that has more than 4 gig, you just can't see that at all. Fortunately, with Windows 7 SP1, it will show you the amount of RAM that is physically in the machine and the amount of RAM that's actually usable, taking into account that it can't see anything above 4 gig, and there are hardware chunks carved out. So you can easily see how much effective RAM can I get to. All the reasoning behind that, if you want to read through all the gory details on those mapped memory segments, you can read through a Mark Russinovich blog posting that he put out a few years back that explains where's this memory going to, and really why you can't do a whole lot about it except move to an operating system that can access much more than that 4 gig boundary. So generally, if you're buying machines that have more than 3 gig of RAM, which really means 4 gig or more, because it's pretty odd to buy something that has, say, 3.5 gig. But if you're buying something with 4 gig or more, you're going to want to run a 64-bit operating system on it. Should be a simple open and closed discussion that if you have the machine that has the memory, you want to be able to leverage that memory, make use of it, but have the operating system make use of it. So let me switch over to my demo machines here and show you what I'm talking about. If we look at the properties of an operating system here, this is kind of the worst case. This is a Windows 7 Enterprise SP1 machine. It's running a 32-bit OS. It has about 6 gig of RAM in it, but only 3.87 is usable. So, okay, we had 6 gig. Windows x86 can only see 4, so that chops it down to 4. And because of the hardware in my virtual machine here, another 0.13 gig is eaten up by the hardware allocation. So that's not terribly good because, well, I can't make use of all of that RAM. If I look at an equivalent machine that's running a 64-bit OS, I see the same picture here, 5.86 gigabytes of RAM, running a 64-bit OS. You don't see any value in parentheses to say that you have a lesser amount usable, so everything is usable. I can use all the RAM that's available in this machine. Now, if you wanted to get into more of the detail on, especially on that x86 machine, if we switch back to that one, if you wanted to see where that 0.13 went to, you can use the MSInfo32 executable, which will show you under hardware resources the memory allocations that have been put into place by various pieces of hardware. And that will explain where did that other 0.13 meg go to. But generally, you don't need to worry about that too much unless you've got a really high-end video card in there, because a video card with a gig of RAM might steal a gig of RAM from your machine, even though it's not using it directly. Nothing can use it at that point. So that really becomes the biggest item, that your operating system should be able to leverage all of the memory that you have put into the machine that you purchased. And these days, given the price of memory, it really doesn't make sense to buy machines anymore with less than 4 gig of RAM. We're seeing standard configurations inside of Microsoft that are 8 gig, 16 gig, 32 gig. Now, we might not be typical, but I would hope that you're not going out and buying machines with 2 gig of RAM, because it saves you $5 over the cost of a machine that has 4 gig of RAM. I mean, we're almost to that point now where 4 gig is the standard configuration. 8 gig isn't that much more expensive beyond that, and 1632 and beyond are within the realm of imagination. I really hope that when I get my next laptop, that my next laptop will have 32 gig of RAM in it, because I would really like to be able to carry my virtual machine environment with me to do demos rather than needing to remote into another machine to do this. But it's going to happen. It's coming along fairly quickly. Now, as far as the OS goes, there are some OS-specific capabilities that can be leveraged with x64. One of them is called PatchGuard. So the operating system can protect itself from being patched by third parties or malware, leveraging some of the hardware capabilities that are only present when running in an x64 OS. That's useful to deter rootkits and any other malicious code. It also has kind of a side effect that it causes antivirus software and firewall software and packages like that to need to go through different interfaces in order to hook into the operating system. Now, when Windows 7 first came out, yeah, that was a bit of an issue. You had to wait for the antivirus and firewall vendors to update their software so that it was compatible. But all of that's long gone. Windows 7's been out for long enough now that there's no compatibility issues between those types of packages. There's also hardware-based data execution prevention, which is useful for a lot of those buffer overrun type issues that a lot of the security updates that come out have to deal with. The basic idea is that any memory not marked executable can't be executed. Seems logical enough that in the case of a buffer overrun, that's usually what people are trying to do. They're trying to put code into a buffer that's meant for data, extending it beyond the boundary of that buffer, and then they try to jump to it and execute it. Well, the operating system will block that. But on x64, that's done by the hardware, where on x86, it's a software emulated process that makes sure that that happens. So there are some additional capabilities in the OS to try to make it more secure. You also have a requirement for signed drivers. So Windows 7 x64 won't install an unsigned driver. They have to be signed, which means that, okay, you're going to have to go back to the vendors and get the official signed drivers, and that's nice, but it also means that you can't do some of the tweaks that you might have done in the past, like editing an INF file to change a default NIC setting to full duplex, or you can't do any manipulations to these drivers. You have to install them as they're provided by the vendor. Initially, probably the biggest thing that held people back for Windows 7 x64 was drivers. That they would need to get the drivers for the hardware that they've purchased and all the peripherals that are attached to it. But the Windows logo process for drivers effectively requires that the vendors create x64 drivers. x86 drivers are now optional. So pretty soon we're going to start to see the situation change around. Instead of having to struggle to find x64 drivers, you may start to see situations where you're struggling to find x86 drivers. We'll talk a little bit more about drivers later on, I believe, but let's switch gears a little bit and talk about UEFI. The Unified Extensible Firmware Interface. How many of you have ever heard of it? A few? Well, I suspect as time goes by, a lot of you will become much more familiar with it, but basically it's a replacement for today's BIOS that every PC runs. I'd be willing to bet that a lot of you in the audience already have a machine that has a UEFI BIOS replacement in it, because every shipping model from HP, from Dell, the latest from Lenovo, desktops, laptops are all moving to this UEFI setup. Now, they all also include fallback support. They include a compatibility module that enables them to emulate the old BIOS structure. So typically when you're installing an operating system into it, you're leveraging this compatibility module, and you really don't know that you have a UEFI BIOS there. But if you do an installation purposely to support UEFI, which Windows supports, then you get some of these additional capabilities provided by UEFI. So why are people moving away from this BIOS and moving to UEFI? Well, this thing's been around forever. The BIOS infrastructure is still 16-bit code. It has a 1 megabyte address space restriction. That's not gigabyte, that's megabyte. So all of these option ROMs that you have on the machine are forced into that very cramped amount of memory where they load themselves in, they do whatever initialization they need to, they unload themselves. They have trouble accessing the hardware that they're trying to initialize from that 16-bit code. So the driver vendors, the device manufacturers, all of them want to move to these UEFI-based environments because then they can use 32-bit and 64-bit initialization code. They don't have any of these address space restrictions, and it's much faster to initialize machines within this UEFI environment. So you see these machines out today. There's also IBM servers. Dell has, I think, announced that they're going to do desktops as well soon, but most machines that are shipping today will support UEFI. As we move forward into the next versions of Windows, we really expect there to be additional capabilities added that more closely leverage these UEFI capabilities. UEFI has the ability to run bytecode even before the operating system boots up, so we may start to see some additional pieces added into there. Like, imagine if McAfee created a UEFI version of their scanner that you could hook in that runs a scan for bootkits at boot time rather than waiting for the operating system to start up and then do the scan. So you get additional capabilities along those lines. Probably the first thing that will drive people to UEFI, though, is disk size. One of the biggest limitations right now with the legacy BIOS is that the master boot record, the MBR, supports a maximum bootable disk size of 2.2 gigabytes. Now, a few years ago, 2.2 gigabyte boot drive sounded like a fantasy, but these days you can go out and you can buy 3 gig IDE or SATA drives, 4 gig, 5 gig. They're starting to get bigger. You might have wondered why. Well, they started at the, did I say gigabytes? I meant terabytes. The 1 terabyte drives came out a couple of years ago. 2 terabyte drives came out not too much longer after that, but then it stopped growing. You started to see some 3 gigabyte drive, or I'm saying it again, 3 terabyte drives recently, but they weren't internal. Most of the 3 terabyte drives that initially shipped were external drives, primarily for this reason, that people would put them into PCs and then try to install Windows to them, and they couldn't do it because either the Windows would just not recognize it because the BIOS wouldn't know what to do when it saw this 3 gig drive, or it would take that 3 gig drive and only show you 2.2 terabytes of it. You know what I'm talking about. We're talking terabytes, not gigabytes. Ignore what I say otherwise. But so we have this barrier that we're approaching, and it's probably going to hit on the consumer side before the enterprise side, because I'd be willing to bet most of you aren't buying machines with multi-terabyte drives in them today. But if you ever try to stick one in and wonder why it doesn't work, well, that's what's going on. Even the vendors out there like Seagate have said that the industry's really not ready for these larger drives because they're not ready for UEFI. So as time goes by, there'll be more awareness, more readiness for this, and you will see this happening over time. When you have UEFI in place, that 2.2 terabyte limitation completely goes away, and now you're up to 16.8 million terabyte support. I certainly hope I don't live to see the day that you put a 16 million terabyte drive into a machine, but that is a potential capability in UEFI. As far as Windows goes, UEFI is only supported when you're doing a 64-bit deployment. So now we're tying back into the 64-bit side of the world. There's no support for x86 OSs. They always will use that legacy fallback support when they're installed on a UEFI machine. The expectation was that x86 machines are kind of on the downswing, that everything's moving to 64-bit, operating systems are moving to 64-bit, so we'll invest in doing this UEFI support for these 64-bit OSs. Now, there have been some twists and turns along the way that have caused some second guessing of that, so who knows, in the future you might see some x86 support for UEFI, but at this point it is 64-bit only. There are some Windows-specific UEFI features, including faster initial booting and faster resuming from Hibernate. The reason that those two are faster is back to that 16-bit code that we were talking about before. When the operating system boots up, it loads an initial bootloader. The bootloader is responsible for loading the rest of the initial operating system files, or in the case of resuming from Hibernate, reading the hibernation file into RAM so that the machine can resume from hibernation. In order to do that, the full operating system isn't around yet, so it has to use 16-bit code, these int13 BIOS calls, to read the disk, to read the files off of the disk into memory. That's not terribly efficient because we're back to 16-bit code, a 1 megabyte address space, so we can't read very much data at a time. When you move to UEFI, though, now we can run 64-bit code, access all of the memory, and do very large I/Os to read that. So these initial boot times will be reduced, and resume from Hibernate will be much faster on a UEFI machine than it is on a standard BIOS machine. They also support in Windows deployment services, multicast PXE booting. So in the case of having, say, a dozen UEFI-enabled machines in your environment, you could PXE boot them and transfer the same boot image to all of them at the same time using multicast. Whereas with the standard legacy BIOS, each one gets its own copy sent via unicast. So you can get more scalability out of PXE booting with a UEFI machine. Now, that doesn't mean this is terribly easy to do, because if you look at the laptops and desktops that have shipped today with UEFI support, their integration with PXE and drivers for the network adapters that are built in really varies by vendor and sometimes by model. So getting a machine to PXE boot via UEFI sounds like it should be easy, but in reality it's not. So definitely try it out with your hardware. I've tried it with a few different vendors, and some work, some don't, but don't assume that this is just a simple flip a switch and I can make use of it now. There is a white paper out there that goes through all of these enhancements, talking about what's done in Windows 7. I'm hoping that we'll start to see some additional information trickle out over the coming months as we move forward with Windows. So when we talk about Windows 7 x64 from a retail perspective, the discussion becomes a lot easier. When you go to HP or Dell or Acer or whoever and order a new PC, in a lot of cases, they don't even offer you a choice between an x86 and an x64 OS. If you choose a machine that has more than 3 gig of RAM, they will ship it with Windows 7 x64. Because the last thing they want is for that person who bought the machine to notice that, hey, I can't use all my memory, I want a refund. So they'll make the decision for you. They'll ship it 64-bit, and for the most part, people haven't noticed. That's a good sign overall. It means that the drivers are there, the apps are working, that everything is working as expected. These days, we think that it's somewhere around 75% of PCs being sold or being shipped with an x64 OS. The exceptions would be machines with less RAM, or also things that don't support 64-bit, including some of the older netbooks and some of the lesser powered slates that run with an older Atom processor. Fortunately, as we go farther down the line, Intel processors and AMD processors are adding that 64-bit support even on the low-end processors, so it is getting there. But at this point, vendors really don't want to have to support 2 operating systems, just like I suspect you don't want to have to support 2 operating systems. So in a lot of cases, they just ship x64 on everything, which is how you can get up to that 75% coverage rate. Now, once they move even further to start competing on hard drive size again, then you may see them starting to ship with UEFI as well. Today in the retail world, shipping a PC with UEFI and GPT and all these other things enabled is pretty much non-existent. You don't see that happening, but some vendor will be the first one to come out and say, guess what, today you can buy a new desktop machine with a 3 terabyte hard drive. At that point, they'll be forced to ship UEFI plus GPT, no MBR. But until that happens, yeah, they're all kind of sitting back and saying, yeah, we're not going to go UEFI yet. I'm sure that's going to change over the next year or so as well. So that kind of frames the whys. I mean, really, you've got 2 main whys. You want to be able to support the additional RAM, and you want to be able to support UEFI and larger boot disks in some situations. Obviously, the biggest driving factor is going to be memory. So everything else equal, why not? Why would you not want to go to Windows 7 x64? Hardware compatibility, software compatibility, obviously those are going to be concerns. Do I have the drivers necessary for these machines? As I mentioned before, probably not a big deal. Just the general inertia of it. I've always used an x86 operating system. I want to continue using an x86 operating system. How do I get past that? So let's dig into those a little bit. In the case of hardware, obviously to run an x64 OS, the hardware needs to support an x64 OS. Since 2006, pretty much every processor shipped supports x64, with the exception of the earlier Atom processors that were used in netbooks. So netbooks actually caused some backpedaling because they had such lower powered, lower capable processors that there was a period of explosion on the x86 side. But now, with the latest Pineview Atom processors, they've even moved into the 64-bit realm. Most ultra-low voltage processors now support 64-bit. Some of the previous ones didn't. But generally, these days, it's hard to buy a machine that doesn't have x64 support unless you're buying the cheapest processors that Intel or AMD are selling. So, general suggestion here, I don't care what you're going to end up deploying, x86 or x64. At this point, if you're buying hardware that doesn't include x64 support in the processor, that's probably not a wise move. You want at least the flexibility to run a 64-bit OS, and the only way you're going to get that is to buy a machine that has a processor that supports it. So let's focus then on the software side. What software issues am I going to run into when I'm running a 64-bit OS? The first one, highest on the list, no support for 16-bit apps. The whole Windows on Windows environment goes away in a 64-bit OS. Some people look at that as a bad thing, that I've got these very old 16-bit apps that I need to run. Well, I look at this as an opportunity to get rid of all that garbage because there's no way to get it to run on a 64-bit OS. The subsystem's just not there. Now, you can have remediation techniques using remote desktop services to a terminal server that's running a lower version of the OS or an x86 version of the OS. You can use Windows Virtual PC. So there are ways that you could temporarily enable the execution of these 16-bit apps while you're working on a way to replace them with something a little more modern. But the biggest thing is you want to get away from them. You don't want to continue running this 16-bit code. So the big thing there is being able to identify what types of apps you have out there. 64-bit apps, no big deal. They'll only run on a 64-bit OS. 32-bit apps will run on an x86 OS or an x64 OS equally well, just with some compatibility issues that we might need to deal with. And then the 16-bit apps would only run on the x86 OS. Fortunately, the App Compat Toolkit, when it goes through and does an inventory of the machines, it can identify which executables are 16-bit, which are 32, and which are 64. Chris Jackson's here this week talking about App Compat, and he has got a blog entry out there that talks about how to query the ACT database to see what 16-bit executables do I have in my environment, what 32-bit executables do I have in my environment, so you can get that information out of the database. The main thing to keep in mind there, though, is that if you query the ACT database and you see a whole long list of 16-bit executables, that doesn't mean you have 16-bit apps. Might not be terribly intuitive, but some applications like Adobe Flash will install a 16-bit file that in most cases it doesn't use. It certainly doesn't use them on a 64-bit operating system, but just because you see those files there doesn't mean that you have an issue. So there'll be some that you'll be able to discard fairly easily. Hopefully you can look at the others and figure out which ones might actually be an issue for you. So 16-bit apps, those are going to be an issue. You need to try to work them out of your environment or come up with another way of running them until you can get them out of your environment. There are other apps where you really just need a 64-bit version. Anything that interfaces at a low level with the operating system. That typically includes antivirus software, firewall software, VPN software. We already talked about those. So you would definitely want to make sure that the vendors that you use for those types of software have 64-bit support. That's pretty much universal at this point. But the one that might not be quite so obvious would be anything that uses a driver. And normally you think of drivers as things that are being used for printers or for display adapters or things like that. But there are also licensing dongles that can be attached to PCs. Generally, they have drivers associated with them. So if you're using any type of licensed software that uses those, make sure that they provide a 64-bit driver for those devices. Now, that typically doesn't mean that you need to run the 64-bit version of the app. You can generally run the x86 version of the app, even on a 64-bit OS, but you need a 64-bit driver to support the dongle, and then the app will talk to the 64-bit driver. So there can be some hybrid scenarios in there. There also can be some application-specific issues, so you need to do some additional testing of apps on Windows 7 x64. The types of things that we'd be talking about would be maybe hard-coded file paths. If you have an app that looks at C program files, ... Well, now if it's an x86 app, it may be installed in program files x86. So that hard-coded reference isn't going to work anymore. Fortunately, those things are easily shimmed. Using the AppCompat toolkit, you can generate a shim that says anytime this app tries to reference this hard-coded path, direct it to this path instead. So it's fairly easy to put those shims in place to fix those applications, but you need to be able to detect those problems in the first place. So you need to go through and test them and make sure that they'll work okay. Most of them generally work fine. You'll just see the occasional poorly written app that's not following Windows development guidelines and gets burned by things like that. As far as the detailed compatibility information that Microsoft has collected, there is the Windows 7 Compatibility Center on the web that has always listed whether the apps are compatible with Windows 7 or not. Several months back, they added an additional set of columns to that data, which now will break apart the x86 compatibility from the x64 compatibility. So at a glance, you can see, is this app compatible with both of the operating systems? That works out pretty well. So let me switch back over to my demo machine here for a little bit. And let's look at this from kind of a compatibility perspective and explore why an app would have issues. Apparently I lost my connection here. So basically an application is going to see one of two different views of the system. It could see a 32-bit view, or it could see a 64-bit view. If I could type my password. In the case of a 32-bit view, Windows is playing some tricks on the application by making it look like there is a separate registry, a separate file system for these x86 apps to run in. And as a result, you get into some rather odd scenarios. So now I have a connection and no virtual machines. We're going to make this a bit challenging. Apparently, I've been testing some hot fixes for Microsoft that caused me some issues with terminal services, but I'm getting rather used to the fix. It's just not the fastest thing in the world. So in the meantime, let me start up a command prompt here. And if we look at the environment on this system, we can see here, just by looking at environment variables, that this machine is running an x64 OS. That's nice. And from that, I can actually infer that I'm in an x86 process. Because if I were to start an x86 process, which I can do fairly easily by going to syswow64, cmd.exe, and look at the environment there, Here, it says that the processor architecture is x86, which normally you would look at and say, well, this is an x86 operating system. It's not in this case because there's another environment variable, architect W6432, that says, no, this is really a 64-bit OS. You're just running inside of an x86 process. There are also environment variables that point to program files and program files x86. So any 64-bit app typically installs in C program files. And then any x86 app will install in program files x86. Well, back to that 32-bit process. The 32-bit process sees both program files and program files x86 pointing to the same place, to that program files x86 folder. So they see and can detect kind of the environment that they're in just by looking at environment variables, but where it gets a little more interesting is I'm going to start that session back up because it's easier to show inside of there. But while it's thinking about that, if I were to go to a 64-bit command prompt here and do a directory of C Windows System 32 and look for defrag.exe. I can see, okay, defrag.exe exists there. That would be a 64-bit executable because I'm on a 64-bit OS and I looked in System 32, so that's the 64-bit version. If I look at C Windows syswow64, which is where all the 32-bit executables reside, for defrag.exe, there isn't one. It's one of the big changes between Windows Vista and Windows 7. In Windows Vista, you had pretty much an x86 equivalent of everything in syswow64. With Windows 7, they cut it back so that you just have 64-bit versions of most things. So, okay, I've only got a 64-bit version of defrag.exe. So no big deal. From this process, I could, from my 64-bit process, I could run that directly. Well, let me move that process out of the way and go back to an x86 one. And let's do the same thing from there. So if I do dir Windows System 32 defrag, doesn't exist. Well, I just looked at it from the 64-bit process. It did exist. I do the exact same thing from an x86 process, and it says, nope, it's not there. Well, that's because C Windows System 32 is transparently mapped in this 32-bit process to point to C Windows syswow64. Well, what if I want to get to the 64-bit files? Okay, not too bad. I can do a directory C Windows sysnative defrag.exe. And there it is. So in a x86 process, C Windows sysnative points to C Windows syswow64, and C Windows System 32 points to, no, it's the other way around. In an x86 process, sysnative points to the System 32 folder, and System 32 points to syswow64. Okay, so sysnative is a useful trick that I can reference sysnative to get to the 64-bit executables. But if I go back to a 64-bit process and do a directory of C Windows sysnative, it tells me file not found. There is no sysnative to a 64-bit process. That leads to some kind of interesting side effects. Which, since I'm not going to be able to get to my machine right now, let's pull up a script from here. It leads to being able to add logic to try to figure out, well, where am I? So like in most of the deployment tools, you'll end up seeing logic like this that says, does the file exist in system root, which is the Windows folder, system 32, in this case looking for Server Manager CMD. If it does, then we're going to use that one. Otherwise, let's check to see if it's in sysnative. If it's there, then we'll use that one. Otherwise, well, let's just assume that it's in the path and make use of that. So you'll see logic like that in various places to kind of let you work dually inside of an x86 environment or an x64 environment. You just need to be able to figure out, where do I have things in my administrative scripts, in my login scripts, in my startup scripts, in the batch files that I run that would run into these types of things? So that's one side, looking at the file system, but what about the registry? Well, same basic picture of the world there. If you look at the registry from the perspective of an x64 process, it will see everything under HKey local machine, software, Microsoft, it's for example. So you have that normal registry view there. But then a 32-bit process sees a different view. It sees what's under this WOW 6432 node. Like in the case of Microsoft, we have various 16-bit applications out there that save their settings in a 32-bit registry hive. Not really a big problem, because generally a x86 app is only looking at its x86 settings, and x64 app is only looking at its x64 settings, and they're not trying to cross between one or the other, from one to the other. But if you do have apps that are trying to query certain Windows registry keys or values from another application or things along those lines, you can run into issues where the app might think that it's going to find a registry key, but it's not really there. We've run into lots of issues like that when applications switch from being 32-bit versions to being 64-bit versions. You'll find assorted things that can break like that. So you'll want to test to make sure that the apps can find things that they're looking for, especially if they're looking for anything inside of the Windows folder, and that they can read registry keys, especially if they aren't registry keys that they're creating themselves. So those are the types of tests that you'll want to perform, in addition to those hard-coded path validations to make sure that things that reference program files specifically will still continue to work. Okay. Next on the list, Office. With Office 2010, you now have a choice. So with Office 2007 and all previous versions before that, it was always x86. Now with Office 2010, there is a 64-bit version. It is functionally equivalent to Office x86. There's no new functionality in the 64-bit version that isn't in the x86 version, with one exception. It can open bigger files. Not a big surprise, because it can use larger amounts of memory. So why would you want to run 64-bit version of Office? Primarily to open larger files. So if you've got Excel spreadsheets that are larger than 2 gig or very complex Microsoft project files, all right, maybe you want to look at the 64-bit version of Office and make use of that. But if you're going to run the 64-bit version of Office, there are compatibility concerns that you need to worry about, like making sure that the add-ins that you're going to use with Office are available as 64-bit versions. 32-bit add-ins won't work with 64-bit Office. They'll only work with 32-bit Office. So anything that gets added into Office, and there are a surprising number of add-ins that get installed by various apps out there, won't work with 64-bit. You could also have issues with any VBA macros that you've created in spreadsheets and Access databases and things like that if they're referencing Windows API calls, because there are differences between the Windows APIs on 64-bit versus 32-bit. Now all of a sudden your macros will be running as 64-bit code, so you'll have to test those out as well. And generally, we would just say, yeah, unless you have some compelling reason to go to the 64-bit version, stick with the 32-bit version in 98% of the cases. We haven't seen anyone who's really deploying 64-bit Office broadly across their entire enterprise. Most people are choosing to deploy the x86 version. A lot of people seem to kind of get wrapped up in the 64-bit everything thinking, so that when I'm going to deploy a 64-bit OS, oh, why would I not deploy a 64-bit version of an app to go along with it when that's available? Well, when that app becomes basically a platform for other things to build on top of, then you're kind of forced into sticking with the 32-bit version as long as you can. So, I'm slowly getting my virtual machines back here. If we were to look at Office on a 64-bit machine, like in this case, I've got Excel running on this computer, and this computer is running a 32-bit OS, so obviously it's going to be a 32-bit version of Office there. If I were to connect to my 64-bit machine and look at the same view of the world here, you can do it. 64-bit operating system. I've got Excel running. You really won't be able to see any difference in Excel. It looks like Excel, big surprise. If you were to look at the task manager, because it doesn't say star 32 after it, we know that this is a 64-bit executable. So no big surprise there that it's a 64-bit executable, no big deal. But functionality-wise, yeah, you're really not going to be able to tell the difference between the two, so stick to the 32-bit version. So the question was, can you have both of them installed at the same time? No, you can't. So you had to install one versus the other, unfortunately. So it's something that's being explored for the future to see, can I run both versions on the same machine? Will that cause more problems than it would end up solving? So it is being investigated, but for right now, it's one or the other. In the case of Internet Explorer, you kind of had the same situation. On a 64-bit operating system, you have both 32-bit versions and 64-bit versions of IE. The big challenge is really the same challenge that you have with Office. You can't load any add-ins or ActiveX controls, any 32-bit add-ins or ActiveX controls into a 64-bit process, where that 64-bit process would be IE itself. So, okay, you can go out and try to find 64-bit versions of those, but generally they haven't been available. The one exception was Java. You could download a 64-bit version of Java, but for something like Flash, there was no 64-bit version. Now, there is a beta version of it available finally now, so in the future there will be a version of Flash for 64-bit IE, but as of right now, you had to go out of your way to install that. So, since the 32-bit version's there, and the 32-bit version is the default, and the 32-bit version works fine, that's the simple solution, is to run the 32-bit version of the browser, even on the 64-bit OS. If we were to look at that from a client perspective, if I have an IE page running here, and if we were to look at it in the task manager, we could see that this is an x86 version of IE, and we can see that Flash is running inside of here, and we could play a video and everything would work fine. If we wanted to start the 64-bit version, we would have to explicitly choose it, and then we get the typical Flash is not installed message here, because we're now in a 64-bit process, which we could see in Task Manager. It's one of these two iExplore processes. And if we click to download it from Adobe, we get taken to a page saying Flash 10.3 is not available for your 64-bit browser. It says use the 32-bit one, but you can get to the Flash 11 beta that includes full 64-bit support. So it's those types of things that you're likely to run into on the IE side. Fortunately, the 32-bit browser works really well, so it's a very easy fallback. So we talked a little bit about the administration already, but just to reinforce that, any scripts that you have that reference explicit locations of files, for program files versus program files x86, for System32 versus syswow64 versus sysnative, you now need to worry about, will those work on a 64-bit OS? Since I would imagine that a few of you have already moved to a 64-bit OS, even when your general population is still x86, you're probably already encountering these types of things. You'll just need to make sure on a broader scale that you don't run into those challenges. Another thing to consider at the same time is if you're running, say, a VB script that references a ActiveX control. Maybe you've downloaded some sample ActiveX control that enables you to get network settings out of Windows. Well, that's going to be either an x86 or an x64 ActiveX control. You can't load that control into a process that is a different architecture. So if you download a 32-bit version, you can only load it in a 32-bit process. Download a 64-bit version, you can only load it in a 64-bit process. You can't cross. The same can also go for PowerShell commandlets. You can download PowerShell commandlets that are 64-bit only or 32-bit only, and they will only run in one or the other type of process. Fortunately, in a lot of cases, the PowerShell commandlets are architecture neutral, so they will actually work with either the 32-bit version of PowerShell or the 64-bit version, but you'll want to test them out just to make sure. So how many of you are using Config Manager? A fair number. It kind of forces you into another round of complications. First has to do with inventory. Well, all of this is really tied to the fact that Config Manager 2007 on a 64-bit OS runs an x86 client. So every inventory that it does, by default, it's seeing the x86 version of the world. So okay, that would be bad. They need to inventory 64-bit stuff as well, so they have added the necessary code to cause it to inventory both x86 and x64. But they're two different places, so they end up in two different lists. So if you're using something like the add remove programs inventory, you'll see that there are two lists of those on a 64-bit OS. One for the x86 installed apps and a second one for the 64-bit installed apps. Not a big deal overall. The other challenge, though, deals with the fact that the client is x86, and as a result, the task sequences that run are running inside of an x86 process. So you might run a script inside of a Config Manager 2007 task sequence expecting it to create a registry key in the 64-bit registry hive. And you look later and it's not there. Well, where did it go? Well, you probably added it to the x86 registry instead. Well, there are workarounds for that. You can go into the Config Manager console. Which we can pull up here. And you can say that I want to disable the file system redirection, which effectively says, run this as a 64-bit process. So on any run command line step, you have this option to disable 64-bit file system redirection. Sounds pretty safe. If I check this, it will cause the command line to run as a 64-bit command on a 64-bit OS. It will cause it'll be ignored on an x86 OS, so it'll run as an x86 process. There's just one additional complication. A lot of times, these commands that you run inside of a task sequence need to interact with the task sequence environment, and they provide a COM control to do that. That COM control is x86. So if you check that box to disable file system redirection, you now can't access that COM control, and as a result, you can't access the task sequence environment to pull variables out of it. So maybe you need to look at certain task sequence variables to figure out what needs to be done. So check that box only when you're sure what you're running doesn't need to access the task sequence environment. That's easy enough to work around because you can typically pass it in. So let's say I want to run something bizarre like notepad.exe, and then I want to pass a particular value into it. In this case, it will substitute in the task sequence variable instead of the %logpath %, and then start the process. But if I were running something else that tried to look up log path on its own, it wouldn't be able to do that. So the workaround would be pass the values in rather than trying to have it look them up itself. Okay, so task sequences can be a little tricky because, well, they're running as x86 code on an x64 OS with Config Manager 2007. So for those of you who are deploying Windows x64 with Config Manager 2007, you'll end up working around this. And the typical workaround might be, well, going back to that defrag case, you may specify something like C Windows sysnative defrag.exe C:. So maybe you want to defrag the hard drive as part of your task sequence, so you put in a step to do that. Works great with Config Manager 2007, running as an x86 task sequence. It ends up starting an x64 process from sysnative. The world's good. Now you upgrade to Config Manager 2012. Well, what is Config Manager 2012 going to do to you? It's going to give you a 64-bit client. And the 64-bit client has a 64-bit task sequencer, and as a result, the 64-bit task sequencer is going to try to start a 64-bit process. Guess what? Sysnative isn't available to a 64-bit process. We looked at that before, so now a lot of those fixes that you put in to make a Config Manager 2007 task sequence work properly need to kind of be unwound in order for it to work on Config Manager 2012. So you will need to do some tweaking along those lines to make sure that the types of adjustments that you've made will work either both in Config Manager 2007 and 2012 using that if type logic, or if you're only going to be using it in one or the other, just by changing that reference back to System32 and everything should be okay. The flip side of that would also be if you have compiled code, maybe you've created your own wizard that you've hooked into a Config Manager task sequence. If it's compiled as 32-bit, it can access the 32-bit environment using the COM control. Well, as soon as you move to Config Manager 2012 and 64-bit clients, now your code needs to be 64-bit so that it can get to the 64-bit COM control this time around. So you may need to do some adjustments like that with CM12 as well. So drivers, we've mentioned these a few times, but the biggest thing is that, well, for a 64-bit machine, obviously you need to have a 64-bit driver. For a 64-bit OS, requires a 64-bit driver. What happens if you try to load an x86 driver into an x86 driver into an x64 OS? It blue screens most spectacularly. So obviously, that's a bad thing. Unfortunately, it will block that most of the time, but a very bad INF, you can actually inject an x86 driver into an x64 OS and it will crash. So you need to make sure that you have the right drivers. You need to make sure that you get the 64-bit drivers for the hardware that you need to support with your 64-bit OS. That was initially a pain way back when in the Windows XP, x64 days. It was nearly impossible to find drivers, but these days, the Logo program requires that vendors submit 64 drivers for vendor certification, with x86 ones being optional. We mentioned that before. So at this point, for any modern hardware, you're going to be able to find drivers for it. It's just generally not going to be an issue. Where you're going to run into challenges would be the old stuff. I have an HP LaserJet from 1995 that I want to run with Windows 7 x64. Well, that might work because there may be a generic HP LaserJet driver that will work, but when you're getting into these really old devices, you may not be able to find a driver for them, and there really is no solution other than throw that device away and buy a new one. It's probably past its prime anyway and uses too much power, and it's time to replace it. So there will be some devices where you need to get rid of them and bring in something else, but generally any PCs that you're buying today, you're going to be able to find the drivers that are necessary to run that. So not a big deal anymore. So from a Gartner perspective, they make the two basic statements about Windows 7 x64. The first one is probably why most of you are here, that enterprises need to establish a position on moving to 64-bit as part of their Windows 7 planning. You have an opportunity to make a decision, so it's a great time to make that decision. They've taken a little bit further and said that by 2014, they expect that 75% of all business PCs will be running a 64-bit version of Windows. Now, that one's caused us to scratch our heads for a while and say, you know, PCs generally have, a 3 to 4 year life cycle. So in order for 75% of the PCs in 3 years to be running a 64-bit version of Windows, that means that probably about 50% of the machines being deployed today have to be 64-bit. And that will ramp up over time, that by the time we get closer to 2014, it's close to 100% in order to hit that 75% average by 2014. That means a huge number of enterprises are expected to deploy the 64-bit version of Windows. When we first saw this back in October 2009, we looked at that and said, is that possible? I mean, can enterprises actually make the leap to 64-bit? At the time, we had app compat issues, we had antivirus, VPN, all these other things were missing, driver problems, etc. And it seemed impossible at the time. But now, looking at it 2 years later, it's quite reasonable to expect that that's going to be true. In 2014, 3/4 of the machines out there will be running a 64-bit operating system, primarily going back to the original discussion because they have more RAM and they want to be able to make use of it. So it's really only a matter of time before your enterprise moves to 64-bit. It's really a discussion of whether you want to do it with the Windows 7 wave, which is starting now. Most of you are probably looking at deploying that. Or is it something that starts with the next operating system, which isn't that far away, and we'll go through that 3 or 4 year cycle. So it is only a matter of time before that happens. We do expect that most machines will be running 64-bit. So the big question really then becomes, well, should I run both? If I try to go entirely 64-bit or try to go entirely 32-bit, there may be some situations where I need to run the other operating system. If I go all x64, I may find some apps that just require x86. Maybe they have a driver that hasn't been updated for x64, so I must run these in an x86 OS. Or the other way around, if I deploy x86, I have some high-end machines that I want to run a 64-bit OS on so that my developers or CAD engineers or anyone who can take advantage of that additional RAM will be able to run a 64-bit OS on it to be able to make use of that. If you do that, now you had to worry about having multiple images, having multiple driver sets, and testing your applications to verify that they work on both x86 and x64. So trying to do that kind of ad hoc and saying, well, you just pick whichever operating system you want, and ending up with, say, a 50-50 split between them is less than ideal because you've doubled your effort with the variety of hardware that you need to support, with the variety of apps that you need to support, etc. But if you can target exceptions, trying to get to, say, 90% on one and 10% on the other, it's probably not that bad because you can then reduce the set of apps, reduce the set of drivers down to just what's needed to support the exception cases rather than the broad population. We're not sure that anyone can really go 100% pure because there's going to be some compatibility issue out there, whether it's hardware that doesn't support x64, an app that doesn't work, a driver that's not available. You'll probably find something that keeps you from going 100% pure one way versus the other, but you should be able to get to that 90-10 ratio without too much work. So then we had to talk about deployment tools. What deployment tools support deploying Windows 64-bit? Every single one of them. Windows Deployment Services, MDT 2010, System Center Configuration Manager 2007, all support Windows 64-bit and have since the original release. All of them actually supported deploying Windows XP x64, even though almost no one used it. But you can do that, no problem. It will be able to deploy that, and you can also use tools like USMT to migrate user data from an x86 OS to an x64 OS. It takes care of all that reasonably well. The one piece that is a bit missing at this point would be UEFI support. If you wanted to do 64-bit and UEFI, there isn't support for that except in Windows Deployment Services, and in the upcoming MDT 2012 release we'll add support for doing UEFI deployments. Config Manager 2007 doesn't really support UEFI, although you can make it work with enough script hacks to your task sequence. The same story is going to be true with Config Manager 2012. Still no UEFI support there. So you can make it work, but generally expect there to be added UEFI support at a point farther down the road when UEFI gets to be a little more mainstream. Now, I mentioned USMT. The only issues that you should worry about in regards to USMT is, first, it's a one-way thing. So USMT supports migrating user data and settings from an x86 OS to an x86 OS, an x86 OS to an x64 OS, or x64 to x64. The one combination it doesn't support is x64 back to x86. So it's kind of a one-way migration that once you've moved to an x64 OS, you can't use USMT to migrate back to an x86 OS. And it's not just that it says in the documentation that it's not supported. If you try to run the tool to capture the user state on a 64-bit OS, and then try to run the x86 version of it to restore the state, it'll give you an error message that says this state was captured on a 64-bit OS, you can't restore it on an x86 OS, and just exit. So it is a hard block that prevents you from doing that. The other thing that you may need to worry about is with USMT is as you're migrating user data, if you're upgrading any of your apps at the same time, say from x86 to x64, USMT is going to assume that the settings that it captures for an x86 app need to be put back into the x86 registry on the x64 OS. So if you upgrade that x86 app to an x64 app in the x64 OS, USMT might put the settings back in the wrong place for the app to see them in order to upgrade them. So if you've done your own custom USMT manifest to customize what gets migrated, there are some helper functions that you can put into the manifest to say, I need to take this into account. Please take these x86 settings and force them into the x64 registry. Even though that doesn't kind of mesh up with USMT's normal way of doing things, you can override that and put that in there. There are a variety of useful links out there to get more information around these. The Windows 7 Compatibility Center, if you haven't checked that out yet, certainly you want to try that. Mark Rusinovich's blog about the physical memory limits around Windows is useful if you want some very deep explanation into where that memory actually goes to. There are various articles out there talking about 64-bit momentum with Windows 7, the 2.2 terabyte partition limits around UEFI and MBR, the benefits of using UEFI with Windows, and really just some general discussions around UEFI as well. I've done a blog posting out there too, which I think I've got up here somewhere, that talks a lot more about UEFI. So you can read through that as well, which describes how we've implemented support in MDT 2012 Beta 1, but at the same time it has to explain what is UEFI, why do you want to use it, what's different about doing deployment, and really trying to then measure the difference. So, okay, I said that it's faster, how much faster? If I take a Dell laptop and install it using MBR versus GPT and UEFI, how much do you actually shave off of that deployment time? Well, it's not necessarily that drastic. Maybe it goes from 50 seconds down to 40 seconds, or in some instances when you're doing an installation, it goes from 14 minutes and 40 seconds down to 13:55. So you're not necessarily talking about really drastic changes, but there are some benefits, and we would expect those to continue to improve over time as the hardware gets optimized. So you can read through those and hopefully get some more useful information out of them. That is everything I wanted to go through. Hopefully that was useful. I think we've got about 5 minutes left for any questions that anyone might have. There's a question up here.
I just wanted to comment on the running 32-bit, 64-bit version of Office at the same time. You can use AppV to do that, and that'll work perfectly.
Yeah, that's a good point, that because AppV would isolate Office from Office, you could actually run the x86 version of Office and the x64 version of Office, either one as AppV and one installed locally, or both as AppV packages on the same machine if you wanted to test them out like that. So that is a good option. There's a question down here.
If you've got a 64-bit OS with, say, 8 gig in the box, but all that you're running is 32-bit apps, can they address the memory above the 4 gig address space?
So the question was, if I have a machine that's running a 64-bit OS with 8 gig of RAM, but I'm running 32-bit apps, would the apps be able to access the memory beyond, say, 4 gig? Not at once. So let's say you're running, let's use Notepad for the absurd example, and say that you launch Notepad and open a 4 gig file. And then you open another Notepad and open another 4 gig file. Now, each Notepad is limited to 4 gig and can't possibly open a file larger than 4 gig. But you can still open 2 of them because the physical memory is really different than the logical address space, so you can make use of the 8 gig of RAM even though you're running 32-bit processes. It's kind of an interesting picture of the world, but you do end up leveraging that memory even with the 32-bit processes just because they have a virtual address space that's different than the physical address space. Sure.
Concerns with AppV going from x86 to x64?
Are there any concerns with AppV going from x86 to x64? At this point in time, no, I don't think so. There were some initial limitations around AppV support for x64, but with the latest releases and service packs and patches that have come out, there is full 64-bit support, so shouldn't be a big issue.
That is running with the same old sequences with no modification?
Yes, yeah, the same sequence applications will work just fine. Anything else? I can hardly see in the blinding light, but I'll hang around up front afterwards, so if there are any other direct questions, certainly come up and see me. Otherwise, fill out your evals. And I do have 2 more sessions on Friday. One is to talk more detail about Config Manager 2012 and how it does OS deployment. And the second one at the end of the day on Friday is all about MDT 2012 and the new functionality that we're adding in that release. So thanks a lot.